Thanks to the organizers and everyone that worked so hard to put this together. It's been a great event. For those of you online that haven't been here this week, we started our update on day one with a GPT-generated summary of our work. And last night at dinner, Christian expressed displeasure that we didn't continue that on day two. And so briefly, as far as I know, this is generated by Jason GPT. So I'm just going to read it briefly. My friends and fellow servants in this public charge, at the conclusion of these 3 industrious days, it becomes meet and proper that we take sober account of the work which Providence has permitted us to accomplish, sustained by the beneficence of the National Institutes of Health and laboring in trust for the American people. We have endeavored to bring order to the hidden writings of nature, that the mysteries contained in the smallest portions of creation may be spoken aloud for the benefit of mankind. All right, thank you. That's it for me. So now to the tool here. This is the QR code for the GitHub for those online or those that want to take a screenshot to access the tool. Our team was myself, Curtis Hendrickson, Dustin Mackey, Jason Williams, and Andrew Freiberger. Andrew is a cautionary tale. He wasn't able to join us after moving a table here in the room. I think they may have banned him for touching the tables. So why should you care about this tool, or what can it do? Why is it significant in any possible way? It's intended to automate tedious investigations to quickly gain context from sequence similarity searches. So you start with some set of queries. You want to interpret the results that are returned from those queries, and this is designed to help with that. It's a pretty small tool. The work that we did was entirely contained within this Codeathon, but it does serve, I think, as an example that actually works. You can clone the repo, and as long as you point it at a GPT resource or a LLM resource that actually also works, you should get some meaningful output. It'll make some calls for you. And so it serves as kind of a hello world MCP, LLM type of bioinformatic thing, if those two things can go together. And it dynamically adapts to scientific guidance for this specific purpose, which again is interpreting results associated with sequence similarity to meet user-specific goals. So it takes a FASTA file and a user prompt, and then it does the interpretation. And we instantiated something we started calling the analysis compass, which is like a decision tree playbook for the common sort of analysis that people would do when conducting such a search. So again, in this era of petabyte scale research or sequencing data, searching through the sort of gestalt of the attributes associated with the sequences that are returned in one of these sequence searches takes a lot of time. And so we're trying to speed that up and make it more convenient. So some features associated with StorySeq is that it automates the similarity search and reference pipeline. It does use MCP to talk to various endpoints, and it synthesizes the data that's returned from several API calls and this sequence similarity search to give a sort of explanation of the sequences that have been returned. I already mentioned it's a command line tool. And right now, our initial implementation focuses on integration with NCBI API calls for doing the blast and the decoration of the subject sequences that are returned. We weren't as brave as the last group, so we did the storyboard of our demo. It does work, but it takes some time. And again, depending on how many people are using your LLM at the time, you may or may not experience some stalling. This is an example invocation here, where the user provided this poxvirus fusion component in a FASTA file, and they had this question, describe the evolution of this organism. Of course, it's in the context of the gene that we provided in that FASTA file, but we didn't tell it that. And then on the right, so you also have some features here about resuming. There's some statefulness in terms of the ability to resume from different portions in the pipeline and from previous results. On the right, you see what's sort of the gussied up version of what you see on the command line when you run the tool. The next several slides just are a continuation of that. So you get some configuration information, and this thing is modular. So again, you can point it at different LLMs via MCP framework. And here's given this question, I'm not going to read the whole thing, but I've just highlighted a few sections. So the query aligns across its full length to known pox virus homologs with e-values that are pretty low and very high bit scores. The identity profile neatly traces organism's position within poxvirity. And then it does some reasoning. Of course, the quality of the reasoning will be dictated by the LLM that you're using. But in this case, we think it did a fairly reasonable job. It's characterizing the selective pressure for the particular gene and in its context of its involvement in infection and why you observe the sort of distribution of alignments that you see that come back. And then it gives this conclusion. What this means for the evolutionary story of the pox virus is that it is a synthepox virus genus whose core entry machinery, again, similar to a spike protein, descends from the ancestral toolkit for the cordopox virus. Caveats and next steps. This kind of text that you see at the bottom under caveats and next steps is driven by the analysis compass, this decision tree, and sort of the caveats that we have embedded. And you can think of it as just a fancy way to do prompt engineering, but it is broken down into sort of the branching decision space. And we thought it was quite useful to do this in this way to try to curtail some of the common abuses of BLAST and homology and that kind of thing. This is just the basic anatomy. You search on BLAST, you extract the data, you enrich it by consulting APIs such as Entree, and then you aggregate all that and pass it to the LLM. So there's actually multiple LLM calls, and that's highlighted here. Everything in yellow is a dynamic sort of runtime behavioral decision, like in terms of what inputs are given, what it finds in the sequence searches, what it finds in the records that are pulled back. And then we pretty much implemented all of this. One aspect we didn't get to, though, is the validation agent. So there, much like in Nick's talk, the idea was to take a set of assertions and then have a sort of adversarial agent evaluate whether those assertions were answered by running this tool. And again, I'm not going to drag you through all the nitty gritty, but we use Pydantic, which is a framework that helps validate that the information you're looking for is actually returned from the tools. So this is an example of using that. We do have the static prompts under revision controls. So there is, when you get results, you can at least tie your commit hash to your results and for some sort of form of reproducibility, although there's no guarantee it's always going to hallucinate in the same way. It uses graph-based orchestration with some asynchronous calls to these different agents that we've defined. And we do have external tool integration. So some of these endpoints that you have heard characterized in the previous talks, we could, as a future development, we could consume those things like the ones from BBBRC or Galaxy or perhaps even the Swiss Institute MCP server. I already mentioned state management and resumable pipelines. So again, it has this sort of resumable capability, which is not dissimilar to Galaxy workflows. It has MCP integration. It has this analysis compass that has a if this then that kind of nature. And it's intended for integration with various types of tools and interfaces. If you want to, say, take your BLAST service on BBBRC and make it invoke this thing also and return some sort of narrative to the user. Our goal is also to make this thing MCP invocable. These are some of the things left on our wish list for this project. And with that, I'm all done.
Thanks,
Thank you.